Chapter 8, Cluster Analysis or Clustering. It is for finding groups of objects in the data set. It is a main task of exploratory data mining and a common technique for statistical data analysis and used for many applications, including machine learning, pattern recognition, and information retrieval, data compression, and computer graphics. The cluster analysis was originated from anthropology and developed from 1930s. This is history. Okay, now we'll go to section 8.1, basics for cluster analysis. Okay, here in this picture, the cluster analysis is illustrated. Now, originally we have three groups of objects, so that once you recognize groups, then intra-cluster distances are minimized. And however, the inter-cluster distances are maximized. And this technique has applications, and the major the task is in understanding and summarization. In understanding, now we try to understand the data set by making groups, and also here by using the representing characteristics from each group, we can summarize and the data set very effectively. And once you are using the labels, then it's not a cluster analysis. That's usually said. However, and why not? Just whatever the available, if you use just available supplementary data components to get better clustering, then it's okay. So that here, original cluster analysis is unsupervised technique. So that if you are using label, so that it becomes supervised classification, then it's not cluster analysis. But this separation is not really clear. Okay. Now, simple segmentation is not a really cluster analysis, and result of query, for instance, in web browsing, then it's not really cluster analysis. Clustering uses only the data and not label in traditional way, so that it is unsupervised learning. The major goal is to discover hidden structures in data. Okay, that is the major thing in cluster analysis. Okay, the quality of clustering can be, as said here, a good clustering method will produce high quality clusters with high intra-class similarity, but low interclass similarity. So that inside of a group, the objects are similar each other, but for other the groups, and the objects are different. Okay. And now quality of clustering result depends on both the similarity measure. That means that in clustering we'll use similarity measure, and also we have to realize through the implementation. So depending on the technique used in implementation, the quality of the clustering result will vary. And quality of clustering method is also measured by its ability to discover some or all of the hidden patterns. That's the major goal in clustering, so that if it can find and all of the hidden patterns, then it'll be really good. Now here, the measuring the quality of clustering, if we say we try to see the conclusion, then here it's not easy. And because one of the reasons is that, and basically, in many cases, we don't understand the data set. And also, the human uses the data, but depending on the person who are dealing with the data, the answer can be different. So that for the quality of clustering, the answer is typically highly subjective. Okay, now dissimilarity, similarity, proximity metric. And similarity is expressed in terms of distance function. So start with distance function, and now along with that, and you can make groups, so that depending on the definition of distance function, your clustering result will be different. And also, distance functions must be defined depending on the data type. And here, usually in the society, and a quality function exists, and that measures the goodness of cluster. And sometimes people are using also weighted measures. But anyway, here it's hard to define similar enough or good enough, because here the answer is typically highly subjective. Okay, here, notion of a cluster can be quite ambiguous. For this data set, you may be asked, how many clusters are there? Then somebody may say that there are 2 clusters, and somebody may say that there are 4 clusters, and maybe somebody may say that there are 6 clusters. So that is quite ambiguous. Okay, here we'll consider a typical similarity and dissimilarity measure between objects. Distances are normally used to measure the similarity or dissimilarity between 2 data objects. Some popular measures include Minkowski distance. That is basically p-norm. So once p is 1, that is called also Manhattan distance. And if p is 2, then the well-known Euclidean distance. Some other distances can be defined to measure similarity and dissimilarity. Okay, various similarity measures have been studied for various data type, and binary variables, and nominal variables, and ordinal variables, and ratio scaled variables, and some vector objects. Depending on the data type, you may try to define the similarity measures. Okay, that's the end of the first part. We'll continue in the second part.